Okay, welcome to demo number 2. We've got Python basics here. So you've hopefully just watched the video I've got on the basic elements of Python and the core building blocks you're going to need to be effective. And now we're going to look at some demonstration of what those do, what they look like. So we've got remember we are in Colab, Google Colab, which is just a place you can run code without having to worrying about setting it up on your local computer. Lots of ways to run Python, but this one is just one that is simple. So I have this here for you in a Jupyter notebook because I like to combine text that helps explain what's going on and what I'm showing you in the code together with the prompt that I would use to get something like this started and then the code itself. So that's what's in this notebook. We're going to go through a number of things. We got to start by authenticating to Google because we're going to use this to pull from Google BigQuery later. So this is getting some basic things installed that we need. Through this, you're going to be asked to authenticate to your Google account. You're going to have to be logged into a Google account to authenticate, and that's what's going to happen here. So I've already done it, so it's probably not going to prompt me for anything special, but this is where you would see the pop-up window that asks you to authenticate and then choose your Google what you have for your Google account, and then you're good to go. It knows who you are. I've made the data sets in BigQuery available to anybody that's authenticated as a Google user. So this is just getting us set up. It's also, you'll see here, putting some variables together for what is the project we're hitting and what is the data set. So this is going to point to that demo hospital system data set that we'll be using through all of class and use it to pull on to demonstrate some things. So let's go to number 1, where we're just looking at the basics. We've talked about a few of these, but a little more directly now through the last PowerPoint that you watched from me. And let's see some examples of variable. A variable is nothing but defining a term in your code that can be reused. So variable can be a number, a string, an object, a list, a dictionary, many different things. So here are 3 different types of variables. One is where we're setting it just to a number. The second is where we're setting it to a list. And you've seen an example of this before where I had the list as numbers. Now I've got the list as a set of strings. And then finally, I've got something new for you. This is called a dictionary. The dictionary, as you recall from our presentation, is a set of key and value pairs. So the key gender has the value F here, and the key zip code has the value 55901 here. So I do a demonstration of using these variables where we print out the age and the patient name at position 0, and we want from that demographics dictionary what is the value for the key zip code. And so you get print age Alice 55901. So that's an example of a few different types of variables and then using them later on in code. All right, next we're going to load up a data frame by querying BigQuery. You saw some examples of this in the past. Here's at the top of each of these, I'm going to put like the AI prompt you could be using in order to get to this same result. And so I'll also point out here that you're going to want to keep a few things in mind. When you're in this environment, this Colab environment, it may not have the full context of your database that you're hitting. And so when we are asking these questions of Gemini in BigQuery, it has that context. When you're over here in another environment, it may not. So you need to feed it that. You're noticing that I'm putting exact column names here as well as reference to the data set name, the table name. So it's gone and actually done a nice job of just building out a query to get us to a data frame that's called df_HSP, and then just to show us the top of that data frame. And here's what we got: CSN patient ID, admission discharge, DRG, and the origin group. And that is coming from the BigQuery data set that you have been using. So there we go. We got that. I'll also pull in patients here. Similar idea. Gathering from BigQuery some information and returning it into a data frame, calling this one df patients. and we just show the head of that data frame. So now that's got it loaded into memory, and we can use it to compute or do things with this data, manipulate it. We're going to start with the compute concept. How can we compute something like length of stay? And we're going to do this with the data set in a vectorized fashion. I share that in our presentation, and that's what's going to be accomplished here. So we bring in pandas and NumPy. Those are two really common libraries, are almost in every Python set of code I've ever created. Then we're going to go and get our date time timestamps set up to have the right format. So I've got a list here of those columns. If I had a longer set of those columns, this would help just more efficiently do this. There's probably other ways to accomplish this, but this is a way to churn through and use a loop. So now you're seeing a loop where I say for each of these columns in that DF hospital, go ahead and take that column and set it to date time. Next, we're going to calculate length of stay within this data set. So you'll see here, length of stay is going to be equal to something you've seen before, where we take discharge minus admission dot dt. And here I'm going a little more explicit, where I go down to the seconds and then calculate what that means in days. And later on, we round it and we put it into the data frame as a new column named LOS days. So now you're seeing just another version of doing something similar that we had done before. All right, I'm going to point out a new capability I haven't shown you before. You are now seeing a way that I'm joining this data in Python. Of course, you've gotten used to this concept through SQL, where you can do a left join of information between two tables. Python enables you to do this too. So you've got some flexibility there. There's not a better or worse. Generally, if you're accessing and going to need to do this regularly, you probably just want to do it in SQL. But you should know, once you get the data here to Python, this is one way that you can manipulate it. So I'm turning this data frame now into a new data frame named joined. And I'm taking that data frame df_hsp, and we're merging it with df_pat. Okay, that patient data frame we pulled in earlier. We're doing a left join on hospital patient ID, the left side of this join, which is df_hsp, is going to join on this column, and the right side is going to join on this column. The type of join is a left join. So instead of writing a statement that says select all from this table, left join onto this other table, this is how we would accomplish that type of thing in Python. So there you go. Next, I'm showing you an example of calculating something given those two pieces of information together. So here's an example where we did not have the date of birth before, but we had a patient ID in our hospital encounter table. Now we've got a table that brings the relevant relevant patient information to our hospital data, and we can calculate what is their age at the point of them getting to the hospital. So that's kind of what we're going to do. So we've joined it, and we've got patient date of birth to be the right type. Got it to a date type, and then we've got age in days. And then we can calculate what is their age at admission by taking the difference between that admission date and the patient's date of birth. You know, you can imagine if they come this year and they're 12 and they get admitted the next year, they would be 13. We can calculate that and we can get it into our data set. Then I go ahead and show the top of that data set just so you can see the example. We've got our columns from the hospital side here, and then we've got our columns from the patient side after that, joined for that particular patient ID. And the last thing that we just did together here is create the age at admission by using the information from both tables. So there, just demonstrating bringing data together and transforming it with Python. Next, we'll do a different type of transformation that you've seen an example of. Now we've got the fuller data set, so you can see that group by DRG and get to some aggregate value. Here we're going to count, and then we're asking to sort that into an ascending order. So we see count of encounters by those DRGs. Here's another type of transformation we might do. We might need to pivot the information so that we've got some record of the rows that we care about spread across different columns. So this is an example where I prompted very simply to get this sort of spread of the information, where the aggregate function is just a count of these records, and we want the columns to be equal to that hospital origin group. The value we're counting is CSN, and the index is going to be the DRG name. So this comes across as pretty readable information. We're saying join, that data frame name joined, I need to create this pivot table, okay? And the index of which will be DRG. And so you see that DRG is here as the row, and the columns I want origin group. Then take a look at that hospital CSN and do a count of that. So it quickly gets us to a table that represents in our data set how many of our chronic obstructive pulmonary disease patients come in through the clinic versus surgical versus a transfer. So that's quick access to pivot and transform our data. And if you were to see the equivalent in SQL, you would see that this is just a much cleaner, more readable way to see this kind of information. From there, Python has an ability to do some visualizations. Now, I would say in general that Tableau is going to be a better choice for doing this quickly and doing it flexibly. But you need to know this exists, it has some potential, and especially once data sets get really large and we have a difficulty processing it with other technologies, this might be an option. This also would be an option for if you really go far with this skill set and decide to do something like web application development. This is an opportunity to create visualizations by pointing at data and then present them forward into an application. So that would be where this would actually be useful, and where we actually use it, today in our team. But as an early learner in advanced analytics and healthcare, you probably aren't going to have the need to very often do visualizations. But I've got a couple for you. First, we're going to put our length of stay into a histogram, and then we'll do another example of grabbing the top 5 DRGs by using that pivot and getting it presentable. So now we get to see from our data that length of stay and how the information is distributed, as well as something like our top 5 DRGs by encounter count. So there you go. That's another example, seeing some visualization with Python and how we accomplish that. All right, let's head into a new concept and topic, a little more utility here. We've got loops and functions. These are really basic building blocks that help us do repeated work. So this is really going to come up when we look at simulation and optimization. So the loop is doing something repeatedly over a set of information. So the set of information is going to be this list here of patient IDs, where we've got 3 patient IDs. And the loop that we're going to do is say for each of those IDs in that list, print out, we're going to process this data for this patient. Just to demonstrate what it is doing, it's looking into the list and grabbing item number 1 and performing this action. Print processing data for that item number 1, and you see the returned result. And then it moves on and loops to the very next piece of work. And so that's what's going on inside of a loop. Let's move on and talk about a function. A function is a reusable building block, a reusable piece of logic or action that you want to be able to take whenever you send information into it. So here's an example to keep with, something familiar. This would be something like, let's go ahead and calculate length of stay. Now I'm doing something as simple as length of stay so that you can just stick with the concept. This would not be an efficient way to accomplish this. You saw before that we would use more of a vectorized approach within the data set, where we're just saying this column minus this column. But this is at least, this is an opportunity to show you how we would take a calculation. It's going to start simple here, but we would move towards this when we have more advanced complex calculations. But to keep the topic approachable and something you can kind of see and understand what's happening, I want to do it this way here. So we're going to start by defining this function. You're going to see that the key word used here is def, and the name of the function is going to be calc.los. Then you're going to see what information does this function need in order to do its job. It's going to need something that we call an admit, something we call a discharge. We've just gone ahead and chosen those terms ourselves so that we can use it within the function. So now it's going to say, all right, you are going to give me admits and discharges, and I'm going to return to you what discharge minus admit in days is. So as an example, if we had an admit date like this here, the 10th of September 2025, and a discharge date of the 12th, we can use those two variables, admit date and discharge date, and send them into calc.los. So we go ahead and call out calc.los, and we put in the admit slot, didn't let me highlight both those, sorry. In the admit slot, we put in the variable admit date, and in the discharge slot, we put in the variable discharge date. Then we print a couple things around it just to make it readable and useful. So here you go. You see the printout of the length of stay is 2 days. So let's put these two ideas together to see some of the power. We're going to start with an example where we've got a list, and in this list is a dictionary. Isn't this interesting? So some of these concepts I showed before, we're nesting together. So we've got a dictionary, and each dictionary has a set of these key and value pairs. So you can see on item number 1, the ID is this patient ID. The admit gives the admit date time, and discharge gives the discharge date time. So that's an example where we can go ahead and build a loop that will call the function for calculate length of stay. So in our loop, we're going to say for every patient, every P in that list above, patients, we want to do the following. We're going to say that the variable LOS is going to be equal to calling this function, where we grab the admit date for this patient and the discharge date for this patient. And think of what this is going to do. It's going to say, for this key admit, go ahead and find the admit, and I'm going to want that value, right, where you get a date time here of what that is. And for that patient, go ahead and look up that discharge key and give me that value. So that is what is happening here, is we're putting the admit date in, putting the discharge date in. We will get a calculation of the length of stay because we've already defined that function above here, so that when we give it an admit and a discharge, it'll give us the difference in days. So let's run this loop and print out what we see. We're going to print for each of these items, print out the value for the key patient, and then tell us what the ID is. And let's go ahead and just say length of stay is going to be equal to that value here that we've calculated for length of stay. So when we do that, it's going ahead and it's finding that that patient, PAT 1001, has a length of stay of 4 days, and it calculates that by sending it into the function. So there you go. That is how we accomplish more complex logic in Python, is with things like loops and functions. Loops allow us to do repeated actions over information, and functions allow us to define more complex logic. Now we've started simply so we don't get too confused, but there's a lot of complexity possible through these basic building blocks. That's all I want you to see for now. Don't get overwhelmed, and please remember that each one of these is created now in a different way than it ever was before. It used to be the case that you needed to spend a very long time, up to a year, studying this language with a ton of effort and time in order to get comfortable and capable to be able to write out even just one notebook like this, when I learned that was the case, I may not even be capable of writing a notebook like this. And I'll be honest, it might take me more than a few days to accomplish this because I wouldn't have had every one of these pieces. I would have had to gone and individually researched how to accomplish a few of these that, maybe I hadn't done in a while or had atrophied in my memory. And now this is something that can be created through generative AI by giving it an appropriate prompt to go and take an action on the relevant context that you're working within. So it is a wild and interesting new world where this is more accessible than ever. That should excite you because it means the stuff that used to be locked away behind years of effort, and only with the select few that decided to do that, is now out and available to you to start solving problems. Less time in the technical detail and more time just solving problems, putting together the information and accomplishing the logic that needs to be accomplished in order to have better information to make better decisions. So, hope that excites you. Stick with us, and we'll keep going.